Right, we're going to do question number 7 now. This question is about esters. So figure 1 shows an incomplete mechanism for the reaction ester with aqueous sodium hydroxide. Add 3 curly arrows to complete the mechanism figure 4. So that's 3 marks, 3 curly arrows. The first one is already done. Then there's a movement electron from this double bond to the oxygen. Okay, forming a negative charge there, which it shows here with a lone pair. The second step, the lone pair moves towards the carbon again, breaks the bond, and this breaks the bond and donates a pair of electrons there. So this molecule, negative charge molecule, is formed. Then this will attack try to attack the hydrogen. The bond will break. There will be movement of electrons from this bond of hydrogen and oxygen to the oxygen, forming negative charge species plus CH3OH. So that's the first 3 steps. Then name the type of mechanism or type of reaction. So they don't want to know mechanism, they want the type of reaction. So the reaction is a base hydrolysis or alkali hydrolysis. Deduce the role of CH3O minus ion in step 3. Step 3 is this one here. So this is the role of this. It works as a base. Triester is a vegetable oil, reacts with sodium hydroxide in similar way. Okay, give the use of product for this reaction. We can use it as soap. Okay, so now we're going to do question number 8. It says the benzene reacts with methanol chloride in the presence of a catalyst. So given the equation for overreaction, benzene reacts with a methanol chloride. Name the organic product. So you both show the benzene. Sorry, it's not looking good there. So C6H6 plus HCOCl goes C6H5CHO plus HCl comes out. And the name is benzaldehyde. Okay. Identify the catalyst in this reaction. Give an equation to show how the catalyst is used to form electrophile. First, the catalyst you can put in there is aluminum chloride because it's chlorine involved there. And then you got to show aluminum chloride working with methanol chloride. And what happens is this aluminum chloride will take away the chlorine. Yeah, so it will form AlCl4 minus and leaving the HCO plus here, which is your electrophile. Now you take this electrophile. It says outline the mechanism for the reaction between a bit of benzene with the electrophile, which is this one you just made, formed. So you got your benzene ring attacking. So the movement of electrons from the inside the localized ring towards the electrophile. Then the electrophile attaches to the ring, but the localized electrons break. You must make sure that when you do the curly arrows towards where it's attached. Okay, so if you do it like that, it'll be wrong. So that curly arrow, not curly arrow, the localized electrons needs to stop here because that's where it's broken. Okay, so it's towards that side, and then that hydrogen will donate a pair of electrons, reform the localized electrons, circle their back, and this at the end is formed like that. Right, let's do a question number 9. This question is about olive oil. A sample of olive oil is mainly the unsaturated fat Y mixed with a small amount of inert impurity. The structure of Y in the olive oil is shown below. So Y is a molecular formula of this, okay, which MR is 880. Okay, the amount of Y is found by measuring how much bromine water to decolorize by a sample of oil using this method. Transfer the weight sample of oil to a 250 centimeters volumetric flask and make up to the mark with an inert organic solvent. So titrate 25 centimeters, so you take 25 after that volumetric flask. Titrate this 25 with of the olive oil solution with 0.025 mol per dm cube bromine. Okay. A suitable target. So titrate. So done that. This is the introduction. So there's a suitable target titer for the titration is 30 centimeters cube, and the concentration is 0.025 of bromine. Justify why a smaller target titer would not be appropriate. So you say smaller titer will increase the percentage error in experiment, okay? Or percentage acidity. Calculate the amount of moles of bromine in the target titer. So you got concentration, moles equals concentration times volume, divided by 1,000. So that gives you 7.5 times 10 minus 4 moles. Right, 9.2. Calculate the supermass of olive oil to transfer the volume to the volume flask using your answer in question 9.1 and the structure of Y. Assume that olive oil contains 85% of Y by mass. Okay, then he says if you're unable to calculate the amount of bromine in the target titer, you should assume 6.25 times 10 minus 4. This is not the correct amount. So we have to work out the ratio between Y and bromine, and the ratio is 1 to 5. Why is the ratio 1 to 5? I'll show it to you. Okay, so if you look at the oil, it's got 1, 2, 3, 4, 5 double bonds. In each double bond, you can breaks down and reacts with a bromine molecule. So you need 5 bromine molecules to react with this molecule, okay, of oil. So because there are 5 double bonds, 5 molecules of bromine is needed to react with each Y. So moles of bromine is then is 7.5 times 10 minus 4. Let me just see if you can see this properly. Okay, and then it says here moles of Y is going to be 7.5 times 10 minus 4 divided by 5. So that gives you 1.5 times 10 minus 4 moles of Y. So in 250 centimeters cubed, it will be 1.5 times 10 minus 3 moles of Y, which is your oil. So then it says here, if they want you to calculate the mass. So once you have the moles, you can work out the mass. So you got the MR, you got the moles. So the moles is going to be this value here, 1.5 times 10 minus 3 times 880, which is given on the top value there somewhere at the beginning of the question. Shows in here. Okay, that's been the question there. And then you work out to be 1.32 grams of oil. Okay, so if you say, they say it's only 85% by mass, because 1.32 is 85%, so how much is 100%? So you got 1.32 times 100 divided by 85, which gives you 1.55 grams. And that's how you do this question, number 9.2. Question 9.3. I think I've done 9.2. So 9.3. It says here the olive oil can be prepared on this method. Place a weighing bottle on a balance and record the mass in grams, 2 decimal places. Add olive oil to weighing bottle until the suitable mass has been added. Record the mass of the weighing bottle and olive oil. Okay, pour the olive oil into 150 centimeters volumetric flask. Add organic solver to volumetric flask. It's made up to the mark. Place a stopper in a flask, invert the flask for 7 times. So just an extra step to ensure that the mass of olive oil in the solution is recorded accurately. So when you get here, put olive oil into 20. So when you put your weighing boat of the olive oil, you should reweigh your weighing boat. So whatever is left over there, you can count as. So reweigh the bottle after transfer the oil and record the mass. That's what you have to do. So it's not all of it that goes in because it's the oil. Say justification, not all the oil is transferred. That's the reason. So state the reason why inverting the flask several times to ensure the solution is homogeneous. Okay? So you should know this technique. You learn when you do your practical. So you should know, you should be able to spot what's missing, okay, before you can answer this question. So you need to prepare yourself for that. Question 9.5. A sample of olive oil was dissolved in methanol and placed in a mass spectrometer. The sample was ionized using electron spray ionization. Each molecule gained electron, hydrogen ion, no electron, it's gained a hydrogen ion during ionization. The spectrum showed a peak of an ion with MZ345 formed from an impurity in the olive oil. The ion MZ345 was formed from a compound with empirical formula, which is this one here. Deduce the molecular formula of this compound, show you're working. So if you know the MZ or MR, you work out the MR from MZ345, you've got to take 1 because you lost a proton. So it becomes 344. So that's for your MR of your molecular formula. So the MR for your empirical formula C5H10O is going to be, you have to add them up, and is 86. So if you take 344 divided by 6 is 4. So that means your molecular formula is 4 times bigger than this empirical formula. So therefore you multiply everything by 4, so it gives you C20H40O4. So that's the answer for your molecular formula. Okay? I hope that was clear. Thanks. Bye. Oh, don't forget to subscribe, please. I'm still need you to subscribe just to see if you are appreciating and enjoying your learning with me. Okay, please don't forget to tick if you like it and let me know in your comments what you think. Thanks. Bye.